All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. Today I have a special guest all the way from Ethiopia. You can introduce yourself so that people get to know you. So what you're doing, where you're studying, yeah, you can.
All right. Thanks for the opportunity. My name's Malboy, or you can call me Mike. Student of Ethiopia Technical University. Currently doing freshman, but because I'm willing to do is civil construction building.
Wow, thank you very much, Mike.
Student.
Thank you very much, Mike. So feel free to ask any questions. So today, most of the questions that we're going to look at are on projectile motion, as you can see on the screen here. So let me just minimize the window here so that, yeah. So basically, projectile motion deals with motion in 2 dimensions. So when you throw something like that, this object is going in 2 dimensions. It is going up, and at the same time it is going forward, going up, at the same time it is going forward. When it reaches this point, it only goes forward. Then when it reaches this forward, it goes forward, goes down, goes forward, and goes down further like that. So that is what projectile motion is about. We're studying the movement of an object in 2 dimensions, in the vertical dimension and in the horizontal dimension. Okay, so now just a few things that you need to know about projectile motion is that when you project an object, let's say this object moves from point A, it flies to point B. Okay, the time it takes for it to move from point A in the horizontal all the way to point B, okay, is the same time it takes to move from down, going up, then coming down here. So that is one thing that you should note, to say the time it takes to move from this point going all the way to this point in the horizontal is the same time it takes to move from the down here going up until it goes down like that. That is the first thing that you should note. So this means that if we cut this in half, if the journey is cut in half like that, if the journey is cut in half, then the time it takes to drop from this point to this point will be the same time it will take to drop from this point going to that point. Is that clear?
Yeah.
So now I am giving you this because this is very important even to this question that is here. You can just read for us the question.
The rifle is aimed horizontally at the target 30 meters away. The bullet hits the target 1.9 centimeter below the aiming point. So part A, they're asking us what is the bullet's time of flight. Then part B, what is the muzzle velocity?
All right, excellent. So as you can see, so this bullet moves in this trajectory there. So until it hits the wall at this point here, okay, it hits the wall at that point. Now remember what we said about time. We said the time it takes to move from this point, from this yellow line here going down, is the same time it takes from it to reach this point. So in this case it is also the same. So the time it takes to move from this point until it hits the wall is the same time it will take to fall from this horizontal line until it hits that point. So what we just need to do is just find the time it takes to move from this point going down here, and we would have found the time of flight. Okay, so here we are also assuming that you know kinematic equations to calculate distance. Can you just share with us the kinematics equation that you know for distance?
For distance, it is d equals to half open bracket VO plus V initial plus V final plus bracket time.
Like this? Is it like
Then
this?
there's another one.
Okay. The other one?
Then time. The other one is D equals to V initial time.
V initial time
Plus a half GT squared.
Sorry? Or GT squared?
GT squared, yeah.
All right. Okay, so on this first one, it has to be the difference in the initial and the final velocity. I don't know. Yeah. So, but I don't know where you're. Yeah, but it has to be the difference between the initial and the final velocity for the first one. So I'm not quite familiar with this one that you've given me on top here, but I think there it should be the difference in the initial and the final velocity. Then the other one.
Okay, the other one is V final equals to V initial plus GT.
V final is equals to
V initial.
Okay, V initial
plus GT.
Plus GT. All right. All right. For distance, the formula that we're just going to need is this formula right here. So this is the formula that we're going to need, because we are looking at we want to calculate the time. So the time, this is the formula that has time. This one I'm not quite familiar with it, but I'll look into it. But this one, that's the one that we need here. Okay, so I can just erase yeah, I can just erase that. Then so for this one, we just need to collect the data now. So we're looking for time. So the distance that we're going to take is this horizontal distance, the 1.9 meters. Okay, so this is the distance that we're taking. So the distance, we can say data there, and for distance we use x like that. Okay, for displacement we use x. So our x in this case is what, 1.9 centimeters, of which we have to convert to meters. What is 1.9 centimeters to meters? All right, so there we're saying we're getting 0.019 meters. So always when you are looking at questions in physics, try to convert the units to their SI units. Okay? All right. So we have our displacement. Do we have G? What value of G can we use?
9.8.
Yeah, 9.8 meters per second squared.
Per second squared.
Yeah, what would be our V initial? What would be our initial velocity?
initial velocity.
So the initial velocity will actually be 0 because remember we're taking the displacement in the vertical. So starting from there, going down there. So the initial velocity there will be 0 because it is falling from there, then it goes down. Okay. So the initial velocity in this case will be 0 meters per second. Then we just put in our formula there. So it will be our x is 0.019 will be equal to, so this part here will be 0 since our velocity initial is 0. Yeah. Then we have, so we can just say 0 plus half. Our g is 9.8. Then we have our t. Yeah, so that is what we're actually looking for. So here we're going to, what are we going to do here?
We're going to multiply a half times the acceleration, which is 9.8.
All right, so this will be 0.019 equal to, so what is a half times 9.8?
4.9.
All right, so 4.9 t squared. Then here, what should we do?
We'll divide both sides by 4.9.
Okay, 4.9 this side, 4.9. So this and this cancels. Then what are we getting there?
We're getting 3.87.
So 3.87. Is that it?
That is it. 0.877.
Okay. All right. You can just check your calculator again. Is this going to give? Is it giving you 3.877? Is it giving you 3.887?
Let me just press the calculator again. 77.
Okay. For your calculator, if you check, there should be like a times 10 to the power something there.
Times 10 to the power negative 0.3.
Yeah. So you should also include that because it's the whole number. So you don't just write 3.887. Otherwise, you miss the mark. Right? So you write everything that is displayed on the calculator. So which is basically 0.00. Yeah, we can just write the one that you've given me. That is what? 3.887. 3.887. What's the value? 3.877
Yeah.
times
Then times 10 power negative 0.3.
negative 3. Yeah. So you should write it like that. So now, yeah. So now we want to, what should we do here for us to have t?
We are going to remove the square root of the square of t by applying square root.
Very good. So we introduce square root this side and square root this side. So this and this can go. Then what is the square root of that number? So on your calculator, you can just say square root, then answer. Square root answer, it will give you the square root of the answer.
We'll get 0.06.
0.06.
2.
All right, 2. Is it O?
2209.
269. All right, so now after you get that, you can approximate now to 0.062 seconds. Okay, so following this strictly, the square root gives us a positive and a negative solution. So, but in physics, we're only interested in the positive solution. That's why we get time as the positive value like that. Yeah. So now back to the diagram. So the time that we found is the time it takes the ball to move from this down going down there. It is the same time it takes the ball to move from the starting point here until it reaches that point. Are you seeing that? So the 0.06 seconds is the time it takes the ball to fall from this height going down, which is the same time it takes to move from this point until it hits the wall that side. So this time. So now when coming to answer our question 2 here, our question 2 asks us to find the muzzle velocity. The muzzle velocity is the velocity the ball is starting with. So the vertical velocity, that's the muzzle velocity here. Okay, so now for the vertical velocity, we use the vertical displacement. Okay, so the vertical velocity will go with the vertical displacement, and simply we can say velocity, we can use, or speed is equals to distance over time, though there are formulas around that, or we can just say velocity is equals to displacement over time. Are you seeing that?
I'm observing.
Yeah. So velocity is equals to displacement over time. So this velocity that we're going to get here will be the velocity that the ball is starting with. Yeah. So velocity will be equals to the displacement we have is 30 meters, and the time we have is the time that we've found here, which is 0.062269. So when you calculate that, what are you getting for your velocity? $481.78. Okay. 78 meters per second. All right, and that will be your velocity in the the velocity it is starting with. Okay. Any questions on this one?
No questions.